Right. Ready? So good morning all of you.
Good morning, sir.
The summary of the last lecture, we have discussed some structures. Simple cubic, BCC, FCC and HC. Okay. Let us change the concept. Okay. Take a fresh page and put the heading density of unit cell. Density of unit cell. Density of unit cell. Right. So this is represented by a row. Unit cell of what? I am discussing unit cell of simple cubic, BCC and FCC. So I hope you understand what is the volume of a simple cubic unit cell. I am not talking about primitive cell, I am talking about unit cell. All unit cells of a simple cubic, BCC, FCC, volume is A cube, don't forget that. Okay, so here I am considering a crystal, simple amma, very easy, listen carefully, crystal. So here I have taken a crystal, let us suppose this one, or solid, anything you can take. So I am assuming the total mass of the solid is a capital M. This is the mass of solid or crystal. Okay. And I am assuming there are capital N number of atoms. Generally order is the Avogadro number. Okay. A capital N. Capital N is the number of atoms. Sorry. Capital N is the number of atoms in the solid or crystal, whatever it is. Okay. So here this solid contains the total mass is capital M, and how many number of atoms are there? Then could you please tell me what is the mass of each atom? Mass of each atom. That means this is the total mass. Sorry, what is this? Total mass. The total mass of the solid is capital M, which contains capital N number of atoms. Then what is the mass of each atom? Mass of each atom equal to, come on I say, M by N. That's good. Now I am taking here a unit cell. Let us suppose this is the unit cell. I already told you this is the unit cell of simple cubic, BCC, FCC. That's why the volume is nothing but how much? Good. And I am assuming the number of atoms per unit cell. For simple cubic it is 1, BCC 2, FCC 4. That's why I am assuming small n. I hope you are observing, where small n is what? Number of atoms per unit cell. Per unit cell. Everything is ready. I got mass of each atom, and the unit cell contains how many atoms? Small n. Okay, that you know. 1 for simple cubic, 2 for BCC, 4 for FCC. What do you want? Density of density. What is the density? That's it. So density is equal to mass. Here the density of unit cell, that's why mass of unit cell by volume of unit cell. No need to get tension, very easy. Mass of unit cell. How many atoms are there? Each atom mass is by, what is the volume of unit cell? That's it. Finally, we can say the rho equal to small n capital M by N AQ. Generally we will use this formula for finding the parameter, not for finding density. Density they will give. We have to find the lattice parameter, because we can't see inside the structure and find the lattice parameter. Density we can find. So many experiments are there, we can find the density. But we can't open the structure and we can't see inside and what is the parameter, what is the distance between crystal planes, all these things we can't see. That's why we will use this to find the lattice parameter. A equal to small n capital M by capital N rho whole power 1 by 3. So finally this n equal to 1, or 2 or 4 for simple cubic, BCC, FCC. Is that clear, ma? Right on. Right. Ready? That's it. That is the density of unit cell row. So, but we are using this to find the lattice parameter. So, please mention this. What is A? I request you, please mention that. Lattice parameter. There will be a ratio A is to B is to C, something like that. Once you got A, we will get the other things also. No need to worry. Ready. Now the next one. This is very crucial. The rest of the algebra completely depends upon this only. Okay. Are you ready? Listen carefully. Miller indices. What is meant by Miller indices? For example, if you consider a crystal. So let us say a simple cubic crystal. This is the one plane and this is the another plane. Like this, you don't have only one box now. You have infinite number. So if you observe carefully, we have this plane, this is the parallel plane, and again one more parallel like that. How many parallel planes are there? Infinite number of parallel planes. All those things I can't represent while I am studying. That's why I need a notation which can indicate or which indicates all the set of parallel planes. So that is called Miller indices. So the Miller indices is simply a notation which indicates a set of all parallel planes. Is that clear? For example, I have written a Miller indices 100. What does it mean? 100, 200, 300, minus 100, all the planes. Are you understanding what I am saying? So all these set of parallel planes are represented by a single notation that is called Miller indices. 1 second. Miller indices. It's a notation. It's a just notation to represent a set of parallel planes. You got a doubt. Set of parallel planes. There will be so many parallel planes. Out of those parallel planes, you are taking one plane. Exactly. Just go back to mathematics. If you have given a matrix, how many eigenvectors you are having? For a given vector, how many eigenvectors will be, for a given eigenvalue, how many eigenvectors are having? Infinite. Adi kuda slow ga cheptaru. No confidence at all. If you go to the interview also like this only. Many times I said, infinite number of eigenvectors will exist. For example, you got 2, 2, 4. Will you take that as an eigenvector notation? What you will take? 1, 1, 2. Because there are infinite number of eigenvectors. Out of all those eigenvectors, you are representing with a single eigenvector, with the smallest integers. The same thing. Here also we have infinite number of parallel planes. Out of all those parallel planes, you are taking one plane. Which plane? Nearest to the origin. So that HKL indicates a plane which is nearest to the origin. That's why if you see some textbooks, they will write like this, a set of smallest integers. Just like our eigenvectors. Is it clear? Good. So I don't want to directly enter into this. I want to take you to first 10th class, and from there I will come back to MSc. Ready? So if you want to get this Miller indices, forget this. Not forget what I explained now. Just this one. Listen. Now in 10th class, I have a two-dimensional plane. For example, like this. This is the x-axis and this is the y-axis. Listen carefully. Now I have a straight line which is having an intercept O. This is A and this is B. The intercept along x-axis is OA and the intercept along y-axis is that you know. What is the equation of line? Equation of straight line. The equation of straight line, this line, I hope everybody remember, x by OA plus y by OB equal to 1. If you remember, x by A plus y by B equal to 1. Just now only started. X by A plus y by B equal to 1. You remember? No, I am not getting good response. The 10th class one I am asking. Now I am going from 2D to 3D. Now I am in the 3 dimension. Whenever you are talking about 3 dimension, straight line is nothing but a plane. That's it. Now I am taking, listen carefully. This is the x-axis, y and z. Let us suppose here we have a plane. Please observe carefully. Ready? So now I am taking this is A and this is B and this is C. So how to get the equation of this plane? The equation of plane, just similar to this equation of line. Come on, say x by OA plus z by OC equal to, where OA, OB, OC are intercepts along x, y, z axis. That's good. Where OA, OB, OC are intercepts along x, y, z axis respectively. Good. Now why you are explaining this, sir? I told you there are set of parallel planes. I am going to represent all those set of parallel planes with a Miller indices, and that plane is which plane it is? Nearest to the origin. So now I want to write the equation of the plane in a crystal. For that I am taking the help of this concept. So equation of a plane is simply x by OA plus y by OB plus z by OC equal to. Now come to the crystal. Now I am talking about the crystal now. I am taking a plane, crystal plane. Listen carefully, please. This is the x-axis, z and y. As usual, I am taking this is A, this is B, and this is C. Just like this. So the OA is the x-intercept, OB is the y-intercept, OC is the z-intercept. In crystal, how we will get this intercepts? Ready? Yeah? Whenever you are talking about a crystal, first you have to talk about the lattice parameters. That means A bar, primitive vectors. A bar equal to AX cap, B bar equal to BY cap, C bar equal to CZ cap. I have taken more general. If they are equal, it is a simple cubic. If two are equal, tetragonal. If three are not equal, orthorhombic. You forgot all this. Simple cubic, cubic, orthorhombic, you remember? So, ready. So, these are the lattice parameters or primitive vectors, whatever it is. But I want this. I want this intercepts. I want this intercept. This one, this one. How to get this? 1 second. Please listen. Okay. So, this is nothing but OB bar. Shall I take it as OB bar? Yeah. So, this OB bar can be written as, everyone please listen, OB bar can be written as, now one more thing. I have taken what? A crystal plane. So, this crystal plane is represented by a Miller indices. What is that? HKL. That you know. That HKL we are going to find now. We are getting a relation. Whenever this plane is represented by HKL and the crystal parameters are A, B, C, then this OB bar equal to, are you observing? OB bar equal to, this is a y axis, that's why B bar by K. Still not understanding? One more. This is OA bar. OA bar equal to, ready? This is x-axis parameter A bar by H. And next this one, OC bar. OC bar equal to C bar by L. We don't want vectors, we want only magnitudes. That's why, one more time, wait a minute, X, Y, Z. So, I don't want to simply give the definition and do the problems, just listen carefully please. Now, it is clear, this is A, O, this is B, C. Now, you understand this OA equal to, don't forget about this vector. Actually, this is A by H x cap. Still, if you are having a trouble, A by H, this is B by K. And this is a C by L. Any doubts, ma? Now, could you please tell me what is this OA? OA equal to only magnitude. How much? Super. Next, OB. This OB equal to? Next, this OC equal to? So, finally, I got OA equal to A by H, OB equal to B by K, OC. That is geometry, Bob. This is simply a geometry. If you have a plane, that intercept is given by this vector by that second coordinate. Is it okay? Right. So, this is OC equal to C by L. Now, go to the 10th class. What is the equation of plane you learn in 10th class? Equation of plane equal to X by OA plus Y by OB plus Z by OC equal to? That's it. Now see, X by A by H plus Y by B by K plus Z by C by equal to. So, what is this? This is the plane equation. This plane, whatever the plane you have earlier, that plane equation. This is the a plane equation. I told you, this plane is which plane? There are parallel planes, but which plane you are taking? Nearest to? If the plane is nearest to origin, that h, k, l must be smallest integers or largest integers? That's why you will multiply there with LCM. In your BSc already you have done. Why you are multiplying with LCM? We need a plane which is closer to the origin. We don't want a plane which is far away. We want a closest one, nearest one. That's why we are taking smallest integers. How we will get? Multiply with the LCM. And some people will say, why you are multiplying with LCM? Make free from fractions. Once you multiply with LCM, there won't be any fractions. And Miller indices are not fractions, not rational numbers. Those are whole numbers. Miller indices is the whole number, not a rational number. Okay, that's why we have to multiply with what? LC. Is that clear? So, this is the equation of the plane, but we need a plane, I hope everybody understand, nearest to the origin. When you will get the nearest to the origin, if and only if h, k, l are smallest integers, that's why you will multiply with the LCM. But my advice, whenever you are doing the problem of Miller indices, the only one equation you have to remember. Everyone, please see the board. Ready? OA is to OB is to OC. What are these? Intercepts. If you see OA, what you have written? That's it. A by H, B by K is to C by L. Just remember this, you will get the answer. No need to worry about anything. Or else, H is to, that means you are writing H. H is to, K is to, L equal to A by OA, B by OB, C by OC. Very few people are saying either this equation or this equation. Any one thing you have to remember. That's it. If they are asking HKL, what is the formula? H is to K is to L equal to A by OA is to B by OB is to C by OC. Where OA, OB, OC, they will give the intercepts. If there is no intercept, no cutting. No cutting means what? A parallel. Parallel means what is the intercept? Infinity. Miller indices is 0. I hope you know all these things, basics. Everybody understand this? Sure. So what is the crystal plane equation? Quite similar to, you will get the reciprocal lattice vector, reciprocal lattice plane also. That's why please try to understand. Come on, make it. Why we need the smallest integers means there are plenty of planes, but we are not bothering about all those planes. We are bothering about the plane which is nearest to the origin. Just like our eigenvectors, infinite number of eigenvectors will be there, but we will take the smallest integer set. But whenever you are doing the problem, please remember any one of that ratio. That is enough. And always make free from fractions. This is a set of whole numbers. Please understand and write. Some points I explained. If you want, you please write those things. They should not be rational numbers, whole numbers. That's why we are multiplying with LCM. I have written the equation of the plane, which is represented by a Miller indices HKL. That's the point. Miller indices should not have comma. If you put comma, it is a point. So don't place commas. The simple concept, x by intercept plus y by intercept plus z by intercept is equal to 1. I mean, x by a plus y by b plus z by c equal to 1, where a, b, c are intercepts. So we need, there I think it's missing, we need a plane nearest to the origin. That's why our H, K, L, these are smallest integers. Why I said small, why I said whole numbers? Here I said integers. Again I am saying whole numbers. Minus we won't write. Minus will be there, but notation, I said clearly it's a notation. We won't write minus. That's why some people will use whole numbers, some people will use integers. It's not a mistake, don't worry. Understand and write. Don't simply copy. This is the last. You won't again study MSc Physics. So, we have to remember that ratio equation, H is to K is to L equal to A by OA is to B by OB is to C by OC, or OA is to OB is to OC equal to A by H is to B by K is to C by L, where HKL is the Miller indices. Ready? All right, stop. Now let us discuss some planes in the crystal. I have taken cubic crystal, that means either simple cubic or BCC or FCC, whatever it is, just simply cubic structure. That is why A equal to B equal to C. Listen carefully please. Now somebody asked in interview, draw 111 plane or 110 plane or 210 plane, like that they are asking. How you will draw? See. Now here first one I am taking 100 plane, simple one we will take 100 plane. Whenever Miller indices is given, if you want to draw the plane, what do you need? Intercepts. Intercepts are reciprocal to Miller indices. Miller indices are reciprocal to intercepts. So that's why, listen carefully please. So here your H is equal to what? 1. K equal to 0. L equal to, first take that. After that, you know what is the intercept? OA. OA equal to A by H. Say yes or no? OA equal to A by H. 1. That's why it is equal to. Cool, cool. Next, OB. OB equal to B. But of course here A equal to B equal to C, that's why I am taking A by 0, how much? Next, very few people are responding, are you interested? Next, again A by how much? Infinity means no intersection. So, your plane is cutting the x-axis at and it is not cutting y and there is no intersection for y and so which plane it is? It's very easy. This is not cutting the z-axis. This plane is not cutting the y-axis. I hope you got it. So this is the plane 1 0 0. Still not understanding? No problem. Just see. Please observe carefully. 0 1 0 I want to get. Same thing. Ready, start. H equal to 0, that's why OA equal to A by 0, how much? Now try to write it directly. Now K equal to 1, then OB equal to A. Next, L equal to 0, that's why OC equal to. So it is cutting the y-axis at. So this is A. Am I right? So only this is the plane which is cutting the y-axis at A, which is not intersecting x and I hope you are observing how I am drawing these planes. That's it, that orange color. Next, third one. Let us take 0 0 1. So now H equal to 0, that's why OA equal to no intersection. K equal to 0, OB equal to no intersection. L equal to 1, OC equal to A. So it is intersecting, the plane is intersecting only z axis. Which plane? This top one. Are you observing? At what distance? A. That's it. This is 0 0 1 plane and this is 0 1 0 plane. Okay, sir, this is easy. Yes. Now come to the next one. So I am going to represent 1 1 0 plane, for example. Ready? Yeah? Now don't get tension, very simple. So first take the cube. Sometimes they will give the diagram and they will ask what is the Miller indices. Reverse. They will give the plane diagram and they will ask what is the Miller indices of that plane. Reverse also you should know. Please observe carefully. If you understand this, that you can understand easily. This is x, y and z. Ready. So, okay. So your h equal to 1. Very few people are responding. OA equal to, next, k equal to, a by L equal to, then, now please go to your coordinate axis, intersect the axis, x axis at, y axis at, okay. Now once you got those 2 points, just join those, over, and once you join this, okay, this is x axis and this is y axis. It is not cutting any z axis. That's why I am not joining. So once you join this, take the parallel line, you know, set of parallel lines, something like that. So parallel lines like this. This line is also not cutting the z axis. That's it. That is a 110 plane. This is okay. Please do this. One more, some planes I have written, 1 minute. 200 plane. How you will draw? They are not asking Miller indices. Miller indices is 100, but they are asking 200 plane. Draw the plane of 200 plane. Ready? Same process, no change. Now your h equal to, same process ma, OA equal to, that's good. Next, k equal to, then OB equal to, next L equal to, then OC equal to. Now come to this. Cool. X axis, y axis and z axis. Ready? Now your x intercept. I hope you are observing. Any intercept on y and z? That's why what you have to take. So that is the plane of 200 plane. Next one, can you draw yourself? Start. I will give another one for you. 210 plane. Oh, no comma, sorry. 210 plane. If you simply copy, no use. I explained how we got that intercept, and after that we are joining those points, nothing else. In the interviews, they will ask you to draw those planes, to represent planes. You should know. So today we will complete this crystal structure. Tomorrow we will enter into reciprocal lattice. After that XRD, X-ray diffraction. Try yourself. 210. Whenever they are asking you to draw the planes, take the Miller indices, and from the Miller indices get the intercepts, because intercepts are reciprocal to Miller indices. That too, parameter by Miller indices, parameter by Miller indices, parameter by Miller indices. Parameters are ABC. Here we have taken a cubic system, that's why all are same. Oh, these lines you should draw horizontally. What does it mean? We are shading the lines now. Just draw horizontally. I draw inclined, no, horizontal. Straight plane, straight plane. Shading represent. Okay, you painted it, very good. Then no problem. It's okay, it's okay. No. It's not a mistake. It's a perfection. So 210. Can you please tell me what is the x-intercept for this Miller indices 2? A by 2. Here, A. Here, infinite. A by 2, A, infinite. I mean. Come on, do it. And show me that diagram. అయిపోయిందమ్మా చూపించు. Correct. Right. So your h equal to 2, I hope you have done. The x-intercept OA equal to A by 2, that's it. And k equal to 1, the y-intercept OB equal to A by 1. and L equal to 0, z-intercept is a by 0, infinity. So it is intersecting only x and y axis. X axis at a by 2, and y axis at a. Now just join these two, okay, and again here, I hope you know parallel, sorry, take a parallel line. That's it. Note, first point, all equally spaced, first point, all equally spaced parallel planes have same Miller indices, Next point, when an intercept is negative, comma, put a bar on the Miller indices, on the corresponding Miller indices. Then put a bar on the corresponding Miller indices. Next point. A normal drawn to the plane, HKL, represent the direction of the crystal planes, in bracket HKL square brackets. So different notations, HKL ordinary bracket Miller indices, HKL square bracket direction indices. Next, wait. This Miller indices contains what? A family. So that is represented by this one. Family of Miller indices is represented by HKL. And this also contains many planes. That's why this family is represented by HKL flower bracket. So these two represent one thing and these two represent another thing. Maybe I reversed it. Exactly reversed. So flower bracket, set of Miller indices. This bracket, set of crystal directions. And you have Miller indices and a crystal direction, and this contains a set of all crystal directions, and this contains set of all Miller indices. I will explain. Just to remember that the notations are different. This is the Miller indices, this is the direction indices, and this is a set of directions, and this is the set of Miller indices. Right up. First problem. If you want to write, I will write here. So HKL there is no space, Miller indices. So HKL, a family of Miller indices. Family of Miller indices. Next, HKL square bracket direction indices. Direction indices. Next, this one, family of directions. Family of directions. So please careful about the symbols whenever you are studying any book. Now first problem. Determine Miller indices of, simple problem, determine Miller indices of a plane parallel to x-axis and cut y and z axis at 2 and 1 by 2, at 2, cut y and z axis at 2 and 1 by 2 in a simple cubic structure. 1 minute, I will explain, next one please do it, listen. So they have given the simple cubic, this is also very important, that means A equal to B equal to C. Whatever the Miller indices problem, please take that formula, that ratio. Don't do any other things. Please, a simple step. H is to K is to L equal to A by, he has given x-axis parallel to x-axis. That means what is the intercept? Infinity. Say yes or no? Very few people are saying. Next, B by, what is the y-intercept? 2. Next, C by, what is the z-intercept? That implies 0, okay, 1 by 2, okay, 2. Sir, why you are not taking ABC? I am taking the ratio. That is the advantage. If you write the ratio, you need not to bother about that ABC. Got it? That's why I am asking you to take the ratio. Now, I told you we have to make it free from fractions. If you want to make it free from fractions, you have to multiply with here LCM is answer. 0 is 2. That's why your HKL equal to 0, 1, 4. Is it clear? Next start, next one. I will write the problems, do it one by one. If you are having problem, please take my help. Otherwise, try to do it. Please take only the ratio. My humble request, take the ratio and make it free from fractions. Multiply with LCM. If anybody didn't understand this, so listen, I am explaining. If you do it, it's no problem. If you already done, no issue. So take the ratio H is to K is to L equal to A by OA is to B by OC, sorry, OB is to C by OC. So it's a tetragonal. Tetragonal means A equal to B but not equal to C. That's why I am taking A only for A. B also I will take A. A by 3 is to A by 4 is to, but unfortunately C is not equal to A, but they have given C equal to 1.5A. That's why I will write 1.5A by 3. This is the advantage, and if you are taking the ratio, that's why you need not to consider A's. So this is equal to, I think you got 1 by 3, 1 by 4, 2 by 3, 3 by 1 by 2, 1 by 2. Now the LCM is how much, Amma? 12. LCM is so LCM equal to 12. That's why I hope you got HKL answer 4, 3, 6. Everybody got this? Come on, next do the third one and fourth one. Yes. Over. Yeah, tell me what is the answer for third question. HKL, what is the answer? 4. Everybody got this? Next. HKL, the fourth question answer. 3? 310. Next problem. Find the Miller indices. Find the Miller indices of a plane. Find the Miller indices of a plane passing through 3 points, with coordinates 0, 0, 1. Commas are given, it's a coordinate, comma 1, 0, 0, and 1 by 2, 1 by 2, 1 by 4. 1 by 2, 1 by 2, 1 by 4 of a simple cubic, Ready? Yeah? Right, stop. Everyone, please listen. So here we know one thing. They are asking Miller indices. Okay, any equation you can take. Intercepts or Miller indices, anything you can take. OA is to OB is to OC. That means this is the ratio of intercepts. Could you please tell me? A by H, B by K, C by, yes or no? Now you know one thing, equation of the plane. Because he has given plane is passing through the point. I already defined equation of the plane is nothing but x by OA plus y by OB plus z by OC equal to, don't by heart, hx by A plus ky by B, don't by heart. So you know this equation and you know this equation. So OA I am substituting A by H, that's why hx by A plus ky by B plus Lz by C equal to, now substitute 1 by 1 point and get HKL. Three unknowns are there, 3 points are there. Because these points, the plane is passing through these points. 3 unknowns, 3 points given. It's a previous gate question. I think from the first point you got L, huh? L equal to L equal to C. I think the first one you will, second one you will get H equal to A. Next, K equal to B by 2. So once you got this, H is to K is to L, it's a cubic, then you need not to bother about ABC. So H how much? 1, and K how much? 1 by 2, and L how much? 1. So multiply with 2, that's why 2, 1, 2. Simple cubic, A equal to B equal to C. So that's why your Miller indices is a 2, 1, 2. Right, ready? Right, so this is about Miller indices. I hope you understand. If you want some more problems, see any textbook and solve the problems of Miller indices. Any DPT book is containing SSP? No, it is not, SSP is not there. Pink color book. Question bank is not there. Finally, while you are actually, our plan is to print the question bank. That what happened this time, printing cost doubled. Earlier 1 lakh taken for one book, now they are taking 2 lakhs. What they are saying, war is going on, that's why. So that's why we combined in that book itself. Again, one more book means 2 lakhs extra is going, that's why we combined there itself. That's it. Okay, anyhow, I think pink color book. Right, ready. So the next one, listen, very important, crystal directions. Listen please, crystal directions. So just a few minutes back I have given the notation, Miller indices notation you understand, crystal direction notation I have given, that is a square bracket H, K, L. What is this, a crystal direction? Let us see, all of you. Now I am taking a cubic crystal, I mean to understand clearly, just I am taking cubic first. So here I have taken a simple cubic. Listen please. Okay, this is the x-axis and a y-axis and a z-axis. Now few minutes back we have already explained the Miller indices. Could you please tell me what is this plane? This plane is cutting the y-axis, that's why the Miller indices 0, 1, 0. Okay, now for example from the origin, I hope you are observing, from the origin if I draw a line normal to this. So this is what? This is a line normal to that plane. This is represented by 0, 1, 0, square. That's it. So that gives the direction of the plane. It's a backward or forward or up or down, something like that. And if you consider one more example, still if you are not understanding, so if you consider this plane, this is cutting the z-axis, that's why 0, 0, 1. This is the Miller indices. I hope you are observing. Now I am considering an axis like this. Okay, normal to that plane, normal to that plane. So that is represented by 0, 0, 1. A line drawn normal to, I have given a point also, normal to that plane gives what? The direction of the crystal plane. Like this we can represent. Now come to more general. Now here I am taking a system. A is not equal to B is not equal to C, but alpha, beta, gamma equal to 90 degrees. Why? Because it's very typical to draw for me. So that's why the maximum possibility is A equal to not equal to B is okay, but alpha, beta, gamma not equal to 90, it's not possible for me to draw and to explain. That's why I'm taking the system alpha equal to beta equal to gamma equal to 90 degrees. So whatever I am deriving now, that is valid only for cubic, tetragonal, orthorhombic. Is that clear? That's good. Don't forget ma. Simple cubic, tetragonal and orthorhombic. That's nice. Okay, Bubble, listen please. Now here I have coordinate axis. Let us say this is x and y and z, something like this. Now here somewhere I have a plane. Somewhere I have a plane, something like this. So this plane Miller indices is given by HKL. Now I am going to take a normal to that plane. That means just a line joining. That means just like this. Okay. Let us say this is the point A, and this is what is the vector here? OA bar. And next I am taking another plane, just like this, something else, some other thing. Okay. I am taking the point here B. So I am taking this. I am taking this Miller indices H1, K1, L1, and I am taking this Miller indices H2, K2, L2. This is the Miller indices. Now I am just joining these two. That means a normal. This is OB bar. Okay. So the OB bar is represented by H2, K2, L2 square bracket, and this OA bar H1, K1, L1 square bracket. And in this direction we have some crystal planes. In this direction we have a set of crystal planes, and these two are called crystal directions. That means in this direction we have so many planes which are parallel planes which are represented by the Miller indices H1, K1, L1. In this direction we have set of another parallel planes whose Miller indices is H2, K2, L2. What we have to find is, we have to find the angle between them. Angle between the crystal directions. This is the question. Are you ready? Right. So we would like to find the angle between crystal directions. Angle between crystal directions. It's a simple OA bar dot OB bar equal to OA magnitude, OB magnitude. What is the angle there? That's why cos phi equal to OA bar dot OB bar by OA magnitude, OB magnitude. That's it. So I hope you will understand what is this OA bar. Could you please tell me what is OA bar? ఏంటి AX x cap, we want to write the vector OA bar. How you will write the vector OA bar? AX x cap. A by H1. Why? we want the vector. How to get that vector? I think it is a H1 A1 ready. So I think OA bar. What is OA bar? How to write? This is H1 K1 L1. We want to write a vector connecting, joining that plane and this one. This is a reciprocal vector. H1 by A should get parameters also. Parameters also we should get, because we cannot take, because we have taken A equal to not equal to B equal to C. That's why A, B, C. We have to get the vectors. What is that vector? See, this OA bar is written as everyone. This is the crystal direction. The OA bar is simply H1 A bar plus K1 B bar plus L1 C bar. That means this is nothing but H1 A X cap, K1 B Y cap plus L1 C Z cap. That's it. What you are saying? You are saying intercepts, I think. No, that is different. So this is the just line joining. We want this line, this vector. This vector is H1 A bar. That means along x-axis. What is the Miller indices? H1. H1 A bar, K1 B bar plus L1 C bar. Similarly, OB bar equal to H2 A X cap plus K2 B Y cap plus L2 C Z cap. Yes, take this. And finally, we got cos phi. Can you make the dot product? Come on. H1 H2 A square plus K1 K2 B square plus L1 L2 C square by under root H1 square A square plus K1 square B square plus L1 square C square. That is a plane. That is a plane equation. We don't want plane. We want a vector. Just a small dot product by magnitude, okay, and after that write for tetragonal and write for cubic. The cubic is very simple, that is cos phi equal to, important, you will get questions, A equal to B equal to C, that's why simply H1 H2 plus K1 K2 plus L1 L2 by under root H1 square plus K1 square plus L1 square. If you see your gate papers, plenty of questions will be there. H2 square plus K2 square plus L2 square. Don't neglect amma. Next here, this cos phi, the tetragonal, A equal to B. That's why H1 H2 plus K1 K2 into A square plus L1 L2 C square divided by under root H1 square plus K1 square into A square plus L1 square C square under root H2 square plus K2 square into A square plus L2 square C square. Write properly. Just I have taken here again the formula and write for tetragonal and cubic. Tetragonal is A is equal to B, not equal to C. Cubic, A equal to B equal to C. I will give two problems just to find the dot product. Plane is different, a vector is different, careful. Just to take two homework problems, because dot product I need not to explain, I need not to waste the time. You can do it yourself. Just take two questions which are gate previous questions. Both are gate previous questions. And they will give Miller indices planes, two planes of, they will give the Miller indices of two planes and they will ask what is the angle between those two crystal directions. That's it. So what is the formula? Please remember this. More general one is this one. H1 H2 A square plus K1 K2 B square plus L1 L2 C square by under root H1 square A square plus K1 square B square plus L1 square C square into under root H2 square A square plus K2 square B square plus L2 square C square. Under tetragonal, take A equal to B, cubic A equal to B equal to C. So simple cubic, at least remember H1 H2 plus K1 K2 plus L1 L2 by under root H1 square K1 square plus L1 square and under root H2 square K2 square plus L2 square. Just take the dot product, just take the dot product. OA bar, OA bar, OB bar I have written. So just take the dot product. Ready? So take the two problems. Easy, Amma, easy. Just they will give HKL and you have to substitute. Write down. Calculate, just write the questions and do it later. Calculate the angle between, calculate the angle between 111 and 001, square brackets, 111 and 001, directions in a cubic crystal. In a cubic crystal means what? What is the formula? H1, H2, K1, K2. Okay, come on. Next, second problem. In a cubic crystal, second problem. Calculate the angle between 111 and 1 bar 1 of a simple cubic crystal. Amma, what is H1 K1 L1? 1 1 1. H2 K2 L2 -1 1. ఓయ్ ఇది ఒంపల్లే ఆడ చైనా బ్యాచ్ అంతా ఏడే ఉన్నారు. అది అనవసరం, అక్కడ ఏముందామని అవసరం. -1 ABC, అది ఏబి ఏంటా మనకు అనవసరం. అది యాక్చువల్గా యూ షుడ్ బోర్న్ బిఫోర్ 19th century. Why? Physics will be very simple because you will think in a rhyming way. That will be very easy. How you think, the result will be like this. Actually, that is a fundamental principle. How you are thinking, the result will be like this. If you are thinking in a difficult way, result also difficult. If you are thinking in an easy way, result is also. If you are not thinking, no result. That's better, I think. I am going to take the next beautiful concept which is not in the textbooks. Listen carefully. Textbooks are given, but they have taken 8th class, 9th class geometry. I hate that geometry. Okay, we are MSc postgraduates. Why should we do that geometry? Cosine law, sine law. Ready? This is a very important. This is a interplanar separation. The last one. Listen. Amma, listen, very important. It's not in the books. Interplanar separation. MSc means whenever you are doing a post graduation means till now whatever you have learned you should use those things. Anyway you can solve. There will be no particular solution for this. That's why different teachers will explain different methods. All are correct, all are good. Ready? So I am taking a system. Here we are going to find the interplanar separation. First of all, what is meant by interplanar separation? That is a plane and that is the parallel plane. Am I right? So the perpendicular distance between two parallel planes is nothing but what? Interplanar separation. Now I am assuming one is at the origin. The other one I am finding. Is it clear? That's why I am taking this as origin. It's easy. 0 0 0. The other one is very easy. Is it clear? That's why I am first making one as the origin and the other plane I am finding. Everybody understand? Good. Now I am taking the more general one. This is, stop writing, everyone please listen. So I have taken this plane which is having an intercept OA and this is OB and this is OC. And this is the plane I have taken. One more plane is at the origin. So this is the plane. Now this plane is represented by the Miller indices H, K, L. Say yes or no? And now I have taken a system. A is not equal to B is not equal to C. but alpha, beta, gamma equal to 90 degrees. Again, whatever the formula I am finding is valid for cubic, tetragonal, orthogonal. Sir, can't you do the other things? It will be complicated. It is in Wahab book. If you are interested, you can see. That is also there. For other systems, that is also a huge, big expressions will be there. Today, go and check. But not required. We will get only either simple cubic or tetragonal maximum. Ready? Boys ready? Yes, girls ready? Yes, right. Yeah, mere null badi poyini. Ready. So this is a plane whose Miller indices is given by H, K, L. Good. So you know that already one relation OA is to OB is to OC equal to A by H, B by K, C by L. So yes or no? That's why OA can be taken as A by H. If you take a vector form, it should be a bar. So yes or no? That equal to A by H x cap. Slowly. Now OB bar. OB bar if you take, this is nothing but B bar by K. This is nothing but B by K y cap. Next one, this is a OC bar. OC bar equal to C bar by L, which is equal to C by L z cap. Sir, why you are doing all these things? Just wait. What do you want? Interplanar separation. Interplanar separation means just now you said perpendicular distance. Am I right? Observe carefully. The two planes I have given like this. Okay? I want perpendicular distance between them. What you will do? If it is like this, what is the perpendicular distance? Straight line. But unfortunately, this is having some inclination, this is having some inclination. Now, but still I want shortest distance. Shortest distance means perpendicular distance. What you will do? What is your idea? I want perpendicular distance. Okay, I will change the word. I want normal distance. Gradient. Whenever you have two planes arbitrary direction, you just take normal to the one of the plane. Normal to the one of the plane. So once you have taken the normal, you just project this plane, I mean this axis into project this axis along the normal. Then what you will get? Projection will be what? Perpendicular distance. Still not understanding? See the board. I will explain. Everyone. Now this is the plane which is represented by Miller indices H, K, L. That's why plane equation from the beginning onwards we are saying x by OA plus y by OB plus z by OC equal to, that implies hx by A. Shall I write directly? Come on. Equal to, that is my plane equation. Now for that plane, Babu listen, I want the perpendicular distance between origin and the plane. Origin and the plane. So first what I am taking is, I am taking a normal to the plane. Textbooks have given cosine law. I am not using that. Simply I am using a small concept. Listen carefully. I have taken a normal. So normal to the plane. Now here I have x-axis. Okay. So this is the normal. What you said? You want perpendicular distance. You want a normal distance. That's why I have taken normal. Now what I will do? Here I got an axis. Here I got a vector. What is that? This vector because of this plane only na. Now I am taking this vector and project along n cap. Project along n cap. That projection is nothing but what? Perpendicular distance. Sir, why you are projecting only this? You can project whatever you want. Either B bar by K or C bar by L. Anything, anything. Because all those three vectors are because of this plane. I don't know how many of you understand once again. We want normal distance, means we want the perpendicular distance, this one, from the origin. This is the normal. Okay. So we want this distance, let us say. This is the DHKL, which is a perpendicular distance or shortest distance, whatever it is. How to get this shortest perpendicular distance? Very simple. I have taken n cap. This is the n cap, and now I am projecting either this vector. What is this vector? OA bar. I am projecting this OA bar along n cap. Then what I will get? Distance. Or I can project OB bar, or I can project OC bar. So dot OA bar or n cap dot OB bar or n cap dot OC. Anything you can take. That means simply projection of this DHKL is nothing but projection of OA bar or OB bar or OC bar along. You know your mathematics are already explained. How to get n cap? N cap is given by del phi by magnitude of. Phi is your plane. Your plane is already there. Hx by a. Okay na? So I hope everybody ready to find del phi. Del phi. Come on, say. Okay, and once you got n cap, DHKL, once again I am saying, I want the perpendicular distance between origin and the plane. That's why I have taken already normal, but I want the shortest. That's why what I am doing is, I am taking this vector and projecting along n cap. You can take any vector out of 3. So that's why DHKL is nothing but projection of, I am taking one of the vector, what is that? OA bar, along. That's it. So I hope everybody understand n cap dot, what is OA bar? OA bar. So finally, DHKL, I didn't use any difficult mathematics, simply take the dot product of this, that is A by H into X cap, A by H, H by A. Understand? Start. If you see Wahab book or any SO Pillai book, they will take a cosine law. In intermediate you have done cosine law, sine law. You remember? Opposite, sine law, opposite something, some rule will be there. Good sister, very good. Say. So similar to that, that is the concept they have used. But we have not used, we have used already this one. I think we learned this in our MSc. Okay, so that's why just to find the n cap, common sense, once you project the vector along n cap, you will get the normal distance. That is shortest distance from the origin. That's it. Any doubts here? So finally, what is the DHKL? 1 by under root a square by a square plus k square by b square plus l square by c square. This is for which system? Orthorhombic. If it is a tetragonal, 1 by under root h square plus k square by a square plus l square by c square. Cubic, a by under root h square plus k square plus. Can you write for those three? See the textbook also. what they have given, you just observe. But do like this only. After that, you please write for tetragonal and a cubic. Plane equation we know, that's why we find the normal to the plane, and after that we just take in a projection because we want the perpendicular distance. That's why we project the OA bar or OB bar or OC bar along a normal. That's it. That is nothing but the distance between origin and the plane, which is the nearest plane. Some problems are there, we will do tomorrow, and tomorrow we will start a reciprocal lattice. So what is reciprocal lattice, why we are using, we will discuss tomorrow. Once X-ray diffraction is over, I think next lattice vibrations, and after that band theory of solids, after that free electron theory of metals, next magnetic properties, superconductivity. If you find some problems in the book, try to do this based on this interplanar separation. Please check the DPT. I think solid state physics questions are there. Please check. Finish it now itself. After 1 month, if you open, you won't get interest also, first of all. So now in this flow, it will complete. Otherwise, it's difficult. SSP ఇంత పెద్ద బుక్, this much big book.
It's SSP and LP. From here, this is
Okay.
nuclear.
Please write for a tetragonal as well as simple cubic also. Simple cubic a by under root h square plus k square plus l square, and tetragonal 1 by under root h square plus k square by a square plus l square by c square. That's it.